Hey everyone, we'll be going over our new calculator on calculating snow loads on a given roof. If we head over here and open up our snow load calculator, it's based off ASE 716 and specifically chapter 7. So we'll go over some of the inputs here as well as the outputs you can expect. So here you can input the ground snow load. And this ground snow load can be found on the ASE 7 hazards tool based on where your site location is. And then the ground surface category has to do with how exposed this building is, as well as how much shelter there is. And then the exposure of the roof has to do with if there's anything nearby or on the roof that's covering a part of the roof. The building risk category has to do with what type of structure you're designing for. And so typically we find for residential, it's typically a risk category 2. And so that assigns the importance factor of 1. And then finally, we have the thermal condition. So depending on if the inside of your structure will be heated, that may cause snow melt on your roof, and that may help reduce the amount of snow load you need to take. So for example, warm roof, there's no reduction, but if it's continuously heated, then there is a reduction. Whereas if it's something like a freezer building, where we don't expect the inside to be heated, then we can expect a higher amount of snow accumulation because there's no chance of melting. And then here we have inputs for roof properties. So we have the distance from eave to ridge. So typically half your roof horizontal distance. And this basically is used to calculate if you'll need a rain on snow surcharge. So typically if the roof is quite flat, then you'll have a rain on snow surcharge, and we'll calculate that automatically. And that value is 5 PSF. The roof pitch, so we typically pull this from the project defaults. You can overwrite it here. And so this accounts for how steep the roof is to account for potential snow slide off from the roof. And then the roof surface type. So if it's obstructed or not slippery, then the snow will grip more onto the roof. And if it's unobstructed and slippery, then can have a reduction in snow accumulation, because as more snow accumulates, there's a higher chance it will slide off. So here we see that if we put in these default values, we get a thermal factor of 1, exposure factor of 0.9, and a roof slope factor of 1. So our flat snow load and our balanced snow load are actually the same. Whereas if we go into a much smaller slope, you'll find that for roofs that are almost flat, there's a minimum snow load requirement that we also account for. So if it's low sloped, there's a minimum requirement, and then a balanced snow load. So if you have sloped roof, then this is actually less than the minimum. And that's it for this calculator. Happy to hear any feedback. And as always, if you need any help, feel free to hit the help button here and ask us any questions. Thanks.